Assalamu alaikum. I am Muhammad Jahangir Alam, lecturer in physics, and I am from Milestone College. I welcome you all in my online class. First of all, thanks to Almighty that He has given me the ability to take this class. Here I also hope all of you are well with your family and staying at home. You are carrying on your regular studies by the mercy of Almighty. Dear students, today we are going to perform an experiment or practical, and our today's experiment is determination of focal length and power of a convex lens. Right? We know what is lens and what is convex lens. So what is focal length? We know what is focal length. The definition of focal length is that the distance of principal focus from the optical center of a lens is called focal length. Right? If the distance of an object from the lens is u and that of that image from the lens is denoted by v and its focal length is f, then the relation between u, v and f is expressed as 1 by u is equal to 1 by f is equal to 1 by u plus 1 by v. Here u and v are the distance of object and image and f is the focal length. So using this formula we can calculate the focal length of the lens. Right? Then the power of the lens. Power of lens can be defined as the capacity of a lens to convert a parallel beam of light into convergent beam or into divergent beam is called power of the lens. So power of a lens is expressed as P is equal to 1 by f m. Here m indicates the focal length must be expressed in meter unit. Right? So dear student, using u and v we can determine then we can calculate the power of the lens. So let's move to the experimental table or optical bench from which we can collect our necessary data, that is u and v, distance of the image and distance of the object. Then we will perform the experiment. Right? So let's move to our experimental table. Okay, dear student, for the experiment, this is the instrument which is known as optical bench. In optical bench, there is a meter scale, and against it there are two rails. Over the rails, there are two pens which can slide over it. One hold a candle which act like the object, and next one hold the optical lens of which the focal length and power is to be calculated. To perform this experiment, the necessary apparatus are a candle, a matchbox, a lens, optical bench, and a whiteboard or a screen. Okay. So when we light out the candle, light from the candle, when refraction will take place in the lens, it will form an image which will caught in the screen. Right? So then we will measure the respective length of the object from the lens and distance of the image from the lens. This distance will considered as u and this distance will considered as v. After measuring u and v, we will be able to calculate the focal length of the lens and hence the power of the lens. Okay, dear student, now let us start our experiment. Dear student, for this experiment we need a dark room because it's a experiment of optics. Here the lens is to be placed almost mid position of the bench, and here we place the bench convex lens at 50 centimeter. So the position of the lens is 50 centimeter. Right? So position of the lens is 50 centimeter. For all reading, the position will be remain at 50 centimeter, and for the first reading we place the candle at 0 centimeter, and the respective position of the image is at we can see that the image is at 87 centimeter. The image is vivid and clear. So the position of the image is 87 centimeter. So position of the object is 0 and position of the image is 87. Right? Now, okay, For the second position, we place the candle at 3 centimeter and the image is found at I think it is clear, almost clear at 90 centimeter. Okay, you can see the image of the inverted image of the candle is at 90 centimeter. So when the position of the object is 3 centimeter, position of the image is 90 centimeter. Now we can set the next position of the object is at 6 centimeter, and for that the position of the image is, I think it is clear at 93, it is 93 centimeter. Okay, position of the image is at 93 centimeter. So when the position is 6 centimeter, position of the image is 93. Now we are going to get the next reading. We place the candle at 9 centimeter, and for that the respective position of the image is I think it is in 96 centimeter. Okay, 9 and 96. Okay, now we are going to get the next reading when the candle is placed at 12 centimeter, and for that position the image is at, the student, in this position the image is clear and vivid, and the position is 99 centimeter. Okay, so when it is 12, it will be 99 centimeter. So using this value we will be able to calculate the fill up the next column. Okay, so E will be obtained by subtracting y from x, and V will be obtained subtracting x from z. Then we will use the formula F is equal to uv divided by u plus v, and then finally we will get the power of the lens, right? Okay, dear student, now we have to calculate the different values of u and v. U will be obtained subtracting u from x. Here the values of u will be subtracted from 50 centimeter. So for first reading 50 minus 0, the value of u will be 50 centimeter, then 50 minus 3, 47 centimeter, 50 minus 6, 44 centimeter, 50 minus 9, 41 centimeter, 50 minus 12, 38 centimeter. Then V will be obtained subtracting x from z. Here the values of z, at z is 87 and x is 50. So subtracting 50 from 87, it will be 37. Then 90 minus 50, it will be 40. 93 minus 50, so it will be 43. 96 minus 50, it will be 46. 99 minus 50, it will be 49. Okay, okay, dear student, using the value of u and v, we can calculate the value of f using this formula uv divided by u plus v. So for the first reading u and v, the respective value of f will be 21.26. The second value will be 21.60. Third value, that is using this value and this value, will get 21.74. Then 21.68. Then 21.40. Okay, now we have to calculate the average value of f. So adding this 5 value, we will divide the result by 5 and we will get the average value as 21.536, right? Then this is the focal length of the lens, but since we have to calculate the power of the lens, we have to convert the value into meter. So after converting this value into meter, the result will be 0.21536. Okay. By inverting this, the power of the lens is f is equal to 1 by f, p is equal to 1 by f. So we will get 0.46. Okay. So power of the lens is 0.46 diopter. Right, dear student, this is a very easy and realistic experiment. I hope you got it. But if you have any confusion, you can contact your subject teacher, and you can also come to our lab and we will clarify it. Okay. So thank you very much being with me in my class. May Allah bless all of you. Assalamu alaikum.